Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Today we will focus on cave formation processes with a particular emphasis on limestone dissolution and speleothem growth. At the most basic level, dissolution begins when rainwater absorbs carbon dioxide from the soil and atmosphere and forms a weak carbonic acid which reacts with calcite in limestone to produce soluble calcium and bicarbonate. The rate of dissolution depends on several controls, including the partial pressure of carbon dioxide in soil air, water temperature, flow dynamics in fractures, and the permeability of the limestone matrix. Speleogenesis often begins below the water table, where rock is fully saturated in Phreatic passages enlarged by dissolution, and as the water table fluctuates or falls, these passages become conduits for Vadose flow, which further shapes cave morphology. When the water table falls, previously flooded passages are ventilated and speleothems can begin to form. Speleothem growth is driven by a reversal of the dissolution chemistry, most commonly when drip water loses carbon dioxide to cave air and becomes supersaturated so that calcite precipitates, forming features such as stalactites, stalagmites, flowstones, and soda straws. Different caves show different speleothem styles and growth rates. For example, Carlsbad Caverns is famous for large flowstones in columns formed where steady, slow drips allowed long-term deposition, whereas some temperate karst systems produce thinner, delicate soda straws. Typical growth rates vary with chemistry and drip rate and are often in the range of a few tenths of a millimeter to several millimeters per year, and biological mediation by microbes can accelerate or alter mineral textures in some settings. A concrete example is Mammoth Cave, where extensive dissolution along fractures and bedding planes created an interconnected maze of passages, and later phases of air-filled passage development allowed secondary deposition of calcite in protected chambers. Finally, it is important to see dissolution and deposition as an integrated system, where recharge through the epikarst, episodic floods, and changes in land use or climate can shift a site from active conduit enlargement to a regime dominated by speleothem growth. Understanding these processes is essential not only for academic speleology, but also for conservation of cave microclimates and for interpreting paleoenvironmental records preserved in speleothems.
Listen again to part of a lecture, then answer the question.
When the water table falls, previously flooded passages are ventilated, and speleothems can begin to form.
This concludes the listening section. For more TOEFL practice tests and study materials, visit spinta.org.